We're going to do the same thing we did yesterday, but now we're going to rotate about the y-axis or a vertical axis of rotation. So we'll start out with a y-axis, and then we'll look at how it's different when we move that axis of rotation. Okay? So now what I want you to think of, kind of like what we did in our homework last week, we did area in terms of dx, then we looked at area in terms of dy. Okay, we're doing the same method, but now we just have to do it in terms of y. So we have these now horizontal rectangles with thickness dy that we're going to rotate about the y-axis. So we can think of our outer radius and our inner radius. So we still have that like right minus left effect that we were having with our area. Okay, and our formula or our setup is going to be the same. We still have pi r squared minus r squared h, but now we're just working in terms of dy because we have a vertical axis of rotation. Okay, I don't know if this is something that you like to write down or not. If you're somebody who likes to write down formulas, this at least would be something, and we're still talking about outer minus inner radius, both of them being squared. So it's the same setup. We're just now going around a vertical axis of rotation. Okay. What's important to think about is that all of these rectangles are perpendicular to the axis of rotation, which is why we're getting these long, thin discs or washers. Right now, that's all you know, but next week I will teach you a method where we're going parallel. And I'll give you some tips how do you keep the two straight from each other. But today, we're doing the same thing we did yesterday, but now it's just in terms of y. Okay? So if we're going to rotate around a vertical axis of rotation, if our equations are not in terms of y, we would need to do that first. Then we can set up our integral with pi r squared minus r squared h. Okay? So I think I have 3 examples for us. So here's the first. I want the volume bounded by the region y equals 2x squared, y equals 0, and x equals 2 about the y-axis. Okay. So 2x squared looks like this, y equals 0, and x equals 2. So here's our area. Well, here's the region, right? Okay. So we are going to rotate about the y-axis, and we're going to do so with rectangles with thickness dy. Okay? You need to draw the rectangle. If you didn't draw the rectangles in your quiz, I'm going to draw them in for you, and you're not going to forget that on Thursday's quiz. Okay? Draw in the rectangles so you can label the thickness dx or dy, and you can see that right minus left. Okay? So one thing that we probably should do before we move to writing the integral, this equation right here that I'm highlighting in green, we don't want that to be y equals 2x squared. Okay? Because we need it to be in terms of y. So if we solve for x, we would have y over 2 equals x squared, right? And so this is going to be x equals the positive radical y over 2. This side of the parabola would be the negative radical y over 2, but we don't care about that one. Okay? Because when we square root both sides, we would have plus or minus, right? But we only have the positive side. So when we look to set this up, we would have pi times the integral from 0 to, not 2. This is the coordinate to 8. Our limits of integration also need to match whatever variable we're using. So 8 is the y-coordinate of that intersection. Okay. So then we have our outer radius would be 2 squared, right? Well, our outer radius is 2, and we square it. Minus our inner radius would just be this distance right here. So radical y over 2, and then we have to square our outer radius. Okay? If you write it like this, I'm happy. If you write it as 4 minus y over 2, I'm happy with that too. Okay, there's really no need to be to really simplify this down. Unless you are going to integrate it by hand. If you're going to put it in your calculator, there's no need. If I don't ask you to evaluate it and I just say, set it up for me, you wouldn't need to reduce it down. The only instance to where I don't ask you to evaluate it, but you would need to reduce it, would be in like a multiple choice question. It would definitely not look like this in your answers. They would write this as 4 and they would write this as y over 2. But that would be the only time. Okay. All right, you want to type that in for me to Math 9? Remember, type this into Math 9 and then worry about multiplying by pi. Hmm? 16 pi? Where's your calculator?
Well, it was like,
You did it in your head? Nice. I like it. Okay, 16 pi. Okay. Nothing different from yesterday. We're just doing it in terms of y because of that rectangle needing to be perpendicular to the axis of rotation. Okay. All right. Example number 2 of 3. We are going to take the region bounded by x squared and radical x. Okay, that's familiar. Wasn't that? Yes, but it was x. Okay. But the region y equals radical x and y equals x squared would be this region right here, right? So we're rotating about the y-axis, and since we're rotating about the y-axis, we're going to need horizontal rectangles with thickness dy. Okay. Which means those equations that I just wrote in blue aren't going to do us much good because we need to be in terms of y. Okay. So instead of y equals x squared, what should we write this as? X equals radical y. Okay? And instead of y equals radical x, we would have x equals y squared. My ability to erase was not that great up here, right? Like I would erase the picture too. So you could probably erase and replace those. I'm just going to do it like this. I know it's messy. So we're going to have pi integral. Now this coordinate of intersection, this is just the coordinate 1, 1, correct? So our limits of integration are going to be 0 to 1. But if we think about our outer radius, okay, our function to the right is that radical y. So radical y would be our outer radius. We square it. Minus our inner radius is that function to the left, which is y squared. Feel like this is a problem I could give you and expect you to be able to find the volume without a calculator. Okay? I don't think that these integrals would be too overwhelming for you, but today I will let you put it into Math 9. See what let's see if somebody else agrees. You got that? Hold on. 3/10 times pi. Please never give me 0.3 pi. That just looks awkward. Okay. 3/10 pi. If it is a decimal, multiply pi through and give me the decimal fraction. Okay. All right, let's take this same region, but this time we're going to rotate it about x equals 10. Okay. So you may need to draw a new picture because we are going to rotate it about x equals 10. So I have my picture up there. I went ahead and labeled x equals y squared and x equals radical y. So now we just have to think about where our region lies in relation to our axis of rotation. Which one's on the right, which one's on the left, okay? Our axis of rotation is to the right, so we will need to start with that, okay? If it were on the left, we would have to start with our region, okay? So we always think about right minus left when we determine inside and outside radius, okay? So we still have pi 0 to 1. I'm going to go ahead and write dy at the end. Outer radius squared and inner radius squared. So our outer radius, the portion of the rectangle that is furthest away is this one attached to the x equals y squared. And our line that we're rotating about is on the right. So we're going to take right minus left. 10 minus y squared. Okay. And then we are going to take our inner radius, which would be this distance right here, 10 minus radical y. Not sure what's happening right there on my board, but it's making all of my numbers look like this. You see what I mean? Okay. This is definitely something that I would either expect you to set up without a calculator or put into Math 9. This is not something I would make you calculate the volume of by hand. So when you put it into Math 9, what do you get?
It's irrational.
Oh man, it's irrational.
I got 20.00.
When you multiply by pi?
Yes.
20.001. So we get an irrational number. It's not something we can change to a fraction. Do not write a decimal with pi next to it. Multiply pi through and give me that approximation. Are you getting what Ethan got? 20.001. So some things we're gonna need to be able to keep straight. Okay. Area versus volume. Area is just the integral of right minus left, or the integral of top minus bottom. Okay. When we get into volumes of rotation, that's when we need our pi's and our r squared minus r squared. Okay. Tomorrow we're gonna learn our last section of 7.2. We're actually gonna take three-dimensional solids, much like we're doing here, but we're going to slice them like bread, and we're going to add up all of those volumes together. Okay. So imagine like taking slices of bread and adding them together. That's what we're doing. So we're going to go through that lesson tomorrow. I am not going to be here on Thursday because I am assisting with the interviews for the assistant principal, and that's going to take me out all 7 periods of the day. So I will leave a review and an answer key for you. But on Thursday, you're really going to have to rely on the help of each other. Okay, you guys are typically pretty good at asking questions, and if somebody asks you a question, I know that you're good at helping each other. You're really going to need to do that on Thursday. Okay. Now, I am still here on Thursday. Before school, I'm not really sure when they haven't told me the exact time. I would guess that I would need to be in the library at 7:30. But I will be here after school. And then Friday I'll be here before school. So if during class you're iffy on some things, either come find me after school on Thursday, I'll be sure to stay even if I get done early. And then I'll be here at 7:05 Friday morning. If you need to come in, just let me know. Okay. All right. So we only have a few minutes left, so we can kind of get organized. On your homework, once again, pay attention to the ones that I ask you to use a calculator on, and the ones that I ask you not to use a calculator on.
I think you should bring in slices of bread, maybe like a fresh loaf.
Oh, like a fresh
so that
loaf.
we can visualize everything.
Oh,
I think
okay.
that would really aid in my learning.
Oh, okay.